Hello everyone, welcome back. Today we are going to take one step forward by using SSH key authentication, a more secure and scalable way to connect. To make logging into the server both easier and more secure, we can use something called an SSH key pair, which consists of a public key and a private key. Let's explain this with a real-world analogy involving a lady, Alice, and a gentleman, Bob. Please imagine this. Bob just got hired at a company. Alice, the office manager, is showing him around.
Hi Bob, welcome on board. Every employee here gets their own office. But here's the twist. Instead of the company giving you a lock, you bring your own padlock and you keep the key. The reason is that you're responsible for securing your own office during your time here.
What this means in SSH world. In this analogy, the office at the company is the user account at the remote server Bob will log into. The padlock is Bob's public key. Anyone can see it. Anyone can see it. That's the reason it is called public key. It locks things up. The key to the padlock is Bob's private key. Only Bob has it, and only this private key can unlock what has been locked with the padlock.
Please give me your padlock. I'll attach it to your office door. You keep the key secure on your end.
How SSH works with the key pair. Bob generates a key pair on his own computer. He gives the public key, the padlock, to the server. When Bob tries to log in, the server uses the padlock to test his private key. And if the public key and private key match, Bob is allowed to get in. No need for Bob to type a password every time, and no one else can log into Bob's account on the remote server without Bob's private key. I hope it is clear. It's a little bit odd, since the padlock is equivalent to the public key. Currently, you might have understood the gist of SSH key pair. It's time for Bob to generate his own key pair.
Alright, let me show you how I create my padlock and key, in tech terms, my SSH key pair, so I can log into a server securely. Step 1. All I need is one simple command. SSH keygen. This command is part of a tool I already have on my system. It comes from the Open SSH client package, which is installed by default on most Linux systems. Step 2. Choose the key type. There are several kinds of lock key pair I can make, but right now, the best one to use is called ED25519. You might hear about RSA, which used to be the go-to choice. But here's why I now choose ED25519. Stronger security at a shorter key length. Faster, especially when logging in or signing things. Smaller key files, less storage, quicker transfers. So I run SSH keygen-T ED25519-C for the job at H holds. Here -T means the type of the key pair, and -C allows me to leave a comment message. I like to do this because it helps me remember what this key is for. For example, for the job at H holds. By default, the key files, the public key and the private key go into my home folder, and the subfolder, .ssh. And I like that. It keeps things tidy and standard. Add a passphrase. This part is important. I'm asked if I want to secure my private key with a passphrase. Yes, absolutely. It's like locking my key inside a private vault. Even if someone steals the private key file, they can't use it without the passphrase. Let's take a look at the .ssh folder with command ls. What is in it? The public key ends in .pub, that's what I'll share with others, like the padlock I will give Alice. The private key stays with me, safely stored and passphrase protected. Now I have got the secure key pair.
I would like to make a summary. First, we can generate key pair with command SSH keygen from the client package. Second, there are several types of key pairs. Currently, it is recommended to use this one with command SSH keygen -t and the type of the key pair. Third, set up passphrase for the sake of security, and you can leave a comment for your own sake. The comment information is kept in the public key. I will tell you how you can check the comment information later. Fourth, it is recommended to keep the key pair at the default SSH folder.
Okay, it's time for me to deliver my public key, my padlock, to the server so I can unlock my office without needing to ask for permission every time. But I just heard the server is using a non-standard entrance, port 2223 instead of the usual port 22. No problem, I can still send over my padlock with this command. Let me explain what this does. SSH copy ID is the command that sends my public key to the server. You can see the name means copy ID. The ID here is the public key. SSH copy ID is also from package open SSH client. -i_.ssh bob.pub says, use this specific public key file. This is my padlock. I means ID here, which picks the public key file for transferring to the server. -p2223 tells SSH copy ID, use port 2223, not the default one. This option allows us to switch to another customized port instead of the default 22. Bob at the IP address is my login information. Bob is my user account on the remote machine. The IP address of the server is following the @ sign. When I run this command, my public key gets safely copied into the server's file from my computer via SSH, but of course, I need to type in my password at beginning of the transferring. Here is something that I would like to make it clear. The file keeps my public key on the server is a file called authorized keys, which is located under the .ssh folder within the home folder of my remote user account. That file only belongs to me, even it lives on the server, under my user account. It is not a server file. It's like attaching my padlock to my own office door, not to the building entrance. I think now I can log into the SSH server without password. Since we have logged into an SSH server with password, you know what command we should use, simply SSH. And since we know due to the security reason, we have another port number 2223 now. This time we are going to use our private key as my identity instead of password, so I need to tell SSH where to find my ID file that I would like to use. And the last thing is telling SSH which user account I would like to log in at which server. Bob is the user account, of course. Yes, since we have set the passphrase to protect my private key file. Here we need to input the passphrase to unlock my private key file. Alright. I am in the SSH server now. Since I have unlocked the padlock to my remote office, I can start my jobs at my remote office. You have a good day.